Good evening, everyone. This is assignment related to topic momentum. In this session, we'll discuss questions and MCQs related to momentum. In the first question, two objects are traveling directly towards each other, then collide. Object A of mass 2 kg initially traveling to the right with a speed of 3 meter per second, and object B is of mass 5 kg initially traveling to the left with a speed of 2 meter per second. What is the total momentum of A and B after the collision? So we know the total momentum before collision must be equal to total momentum after the collision. So this is object A and another object B is there. A is having a mass of 2 kg and it is moving with a speed of 3 meter per second. B is having a mass of 3 kg, 5 kg, and it is having a speed of 2 meter per second. So according to conservation of the momentum, the total momentum before collision is equal to total momentum after collision. So momentum before and momentum after should be same. So object A initially moving with a speed of 3 meter per second and object B is initially moving with a speed of 2 meter per second. So if one of the direction, like example, velocity is a vector quantity, momentum is a vector quantity. So if one of the direction we consider as positive, so example, if right hand side I consider as positive, then the left hand side direction should be considered as negative. So what is the initial momentum of A? 3 multiplied by 2, so that for momentum of A is 6 kilogram meter per second. What about momentum of B? That is 5 multiplied by 2, but that 5 multiplied by minus 2, so it will be minus 10 kilogram meter per second. So what is the total momentum before they collide with each other? So the total momentum before they collide, it will be 6 plus, and momentum of B is minus 10. That is equals to total momentum after collision, or x. So when we solve this, this will come out as minus 4. So total momentum after collision will be minus 4. So what is the significance of this negative sign? Negative sign shows that the direction of the momentum will be left. So the direction of the momentum will be there on the left hand side, and the value of the momentum, the magnitude of the momentum will be 4 kilogram meter per second. Is it clear, this question? Any doubt in this one? So we use the concept conservation of the momentum in an isolated system. The total momentum before collision is equals to total momentum after collision. In question 2, which is a structure question, the photograph shows a fireboat used to put out fires on a ship at sea. A pump fixed to a boat pumps water from sea. The seawater is projected at high speed out of the pipe which is connected to a pump, as you can see in the picture. The mass of a seawater pumped each second is 300 kilogram. The diameter is 10 centimeter and the density of a seawater is 1030 kilogram per meter cube. Show that the speed at which the seawater is projected from the pipe is about 37 meter per second. So first what we will do, because we need the speed here, So speed is distance divided by time. And we have the pipe has a diameter. So diameter of the pipe is given, from which the water is coming out. That is 10 centimeter or 0.1 meter. That's a diameter. So using this diameter, we'll work out the area, and using the density and mass, we'll work out the volume. And this is a mass which is flowing per second. So first we will use the density. Density is mass per unit volume, which is given 1000. So we know density is mass per unit volume, or volume is equals to mass divided by density. So the mass is given 300 and the density is given 1030. So this will give us the volume flow, which is 0.291 meter cube per second. Why meter cube per second? Because in the question the mass is actually mass per second. So this will be the volume per second. Then using a diameter, we'll work out the area. So area is equals to pi r square. Pi is 3.14 and radius is half of the diameter, so 0.05 square. This will give us 7.85 into 10 to the power minus 3 meters square. That is the area. So we have the area and we have the volume. How we can find the speed? So basically the volume flow, because we know the volume divided by area, that's the volume flow. So volume per second divided by area, what we'll get? We'll get distance divided by time, and distance divided by time, that will be equal to speed. So the volume flow we calculated 0.291 divided by the area, which is 7.85 into 10 to the power minus 3. So this will give us 37.1 meter per second. Is it clear? Discussion that how we work out the volume flow. Uh, Using a volume flow, how we work out the speed at which this water is coming out. As this one, because the mass of a seawater pumped each second, so it's not only the mass, it is mass per unit time, or mass divided by time. Determine the rate at which the momentum of a seawater changes by the pump. You may assume that the seawater initially is stationary. So rate of change in momentum, or change in momentum, we want to calculate. Initially it is at rest, and the change in momentum is equals to final momentum minus initial momentum. And rate of change in momentum is also equal to the applied force. So that is equals to final momentum minus initial momentum divided by the time. So final momentum minus initial momentum divided by time. So we are finding a rate here. Final momentum is mv, initial momentum is mu, and divided by time, that is equals to t. Because dimension initially we consider that it was stationary, so if initially it was stationary, so the initial momentum will be 0. So we can write mv divided by t. So m is a mass, v is the speed at which it is coming out, and t is the time. As I mentioned, it is taking 1 second, so time is equals to 1 second. So the mass was given 300, speed is 37.1, and as I mentioned, the time is 1, so we will get this as 1.1 into 10 to the power 4 kilogram meter per second square, which is also Newton or the unit for the force. Projecting water from pipe causes the force to be exerted on the pump. So when the water is coming out, it is exerting force. Explain the direction of the force on the pump. So when the water is coming out, it is exerting force on the pump. The question is, what will be the direction of the force on the pump? So basically, pump is forcing the water forward. So water will, according to Newton's third law, what is happening? The pump apply a forward force to water. So as the pump is applying a forward force to water, so by Newton's third law, the water will apply equal force but opposite direction. So the force by the water on the pump will be backwards. Is it clear? So using a Newton's third law, we can work out the direction in which the force is applied on the pump by the water. In part C, initially the pump is turned off and the fireboat moves forward through the water at a constant speed. So initially the pump was not working and the fireboat was moving with a constant speed. The boat engine provide a constant forward force. When a pump is turned on, the water is projected forward and the fireboat slow down to a lower constant speed. Explain why the boat now has a lower constant speed, and your answer should include reference to all horizontal forces on the boat. Like initially the boat was moving at a higher constant speed, but when it is the pump is operated, it is moving at a lower constant speed. So initially, why there is a constant speed? The boat was moving with a constant speed because drag force, the force which is opposing the motion, was equal to forward force. But when the pump is on, it gives resultant force backward, like there's a backward resultant force, so the boat slow down. And then again it move with a constant speed. So why it move with a constant speed? Because when the speed decrease, the drag will also decrease. Until it balance with the forward force again. So boat will continue to move lower constant speed. So this is the answer which explained like why the boat slowed down as it was moving. First, the pump was not working, and then the pump started to work. So there's a backward force which opposes the motion of the boat, and the boat slowed down. And when the boat slowed down, the drag force decreases until the backward force balances with the forward force again, and the boat continued to move with a constant speed. Is it clear? In question 3, a game is played where each player uses a mallet to hit the disc, across the table into opponent goal. One player accidentally let go of a mallet, and the mallet travels at a speed of 1.6 meter per second and collide with the stationary disc. After the collision, the mallet continue in the same direction at a lower speed of 0.3. The disc move in the same direction with a velocity v. Calculate the v. So how we can calculate v? According to conservation of the momentum, the total momentum before collision the sum of momentum before collision is equals to momentum after collision. So the mass is given for a mallet, the mass is 0.17. For the disc, the mass is 0.035. This is 0.17 and 0.035. So when we find the momentum before collision, so it will be 0.17 multiplied by 1.6 plus 0.035 multiplied by 0. Why? Because initially it is at rest. And after collision, it will be 0.17 multiplied by 0.3 plus 0.035 multiplied by v. So when we solve this, as we know, the total momentum before is equals to total momentum after. So 0.17 multiplied by 1.6, so that is equals to 0.272. This will be 0. 0.17 multiplied by 0.3, that's equal to 0.051. And 0.035 into V. This will move other side. So 0.272, this will move other side, minus 0.051, that will be equal to 0.035 into V. And then V will be equal to the difference of the two divided by 0.272 minus 0.051 divided by 0.035. So the V is equals to 6.3 meter per second. So 6.3 meter per second is the value for V. Is it clear? To reach the goal, the disc must move up a ramp which is at an angle of 30 to the horizontal. The velocity of a disc at the bottom of a ramp is 5, so that is 5 meter per second. The disc move up ramp and work is done against the friction. The disc move at a distance of 6.3 centimeter up a ramp before moving back down. Determine the frictional force. So it moves 6.7 centimeter on the ramp. So initially it is having a kinetic energy. When it rises up, it will have potential energy, and the difference of the two energies is equal to work done against the friction. So when we work out, it moves 6.5 centimeter, which is equals to 0.065 meter. We have the angle. So basically what happened, the conservation of energy before moving on the ramp, it will have all kinetic, but when it rises up, it will have potential at this point. And some of the energy is lost to work done against the friction. So we can say the equation kinetic energy is equals to potential energy plus work done against the friction. So kinetic energy is half mv square, and the distance which it moves, here we know the angle. This angle is given 30 degrees. So if this angle is given 30 degree, against with an angle it will be cos theta, and against the angle will be sin theta. So this will be the height through which it rises, this h, that will be equal to 0.065 sin 30, because that's the perpendicular, so it will be sin 30. And we know kinetic energy is half mv square. So when we use all these values, that kinetic energy changes into potential plus work done against the friction. Kinetic energy is half mv square. Potential energy is mgh plus work done against the friction, so force into distance. And we know the distance moved on the ramp is already given, so we just substitute these values. Kinetic energy will be equal to half, mass is given 0.035, that is in the previous part, and speed at which it enters, that's 5. And potential energy m, the mass is 0.035 multiplied by 9.81 multiplied by height 0.065 into sin 30 plus force into distance. The force is there and the distance is 0.065. So when we solve this, the friction force will come out as 6.56 newtons. Is it clear, this part? So we calculated the kinetic, we calculate potential, we take a difference to get the work done, and work done is equals to force into distance. So we know the distance, so we can find the force. In question 4, a car travel north, so we have the direction north, south, east, west. So a car travel north with a velocity of 50, so it is traveling towards north with a velocity of 50. While traveling, the car slowed down to a velocity of 20. So it does not change the direction, it only changes the velocity to 20 meter per second. Which of the following is a change in the velocity? So change in the velocity or difference in the, it does not change the direction, it only changes the, so the change in velocity or delta v, which is final minus initial of v minus u. So v is equals to 20 minus u is equals to 50. So 20 minus 50, that's equal to minus 30 meter per second. So B is the right answer for this. In question 5, which of the following quantities has SI base unit kilogram meter square second? So when we work out for force, F is equals to ma. So mass is kilogram and acceleration is meter per second square. So it cannot be a. Momentum, which is mv. So mass is kilogram and velocity is meter per second. So again, it cannot be. Power. Power is work done per unit time or force into distance divided by time. Force is Newton, distance is meter, and time is second. And Newton itself, it is kilogram meter per second square, then multiplied by meter second. So when we simplify this, it will come out kilogram meter square second power 3 or kilogram meter square second raised to power minus 3. So C will be the right answer. What about work done? Work done is equals to force into distance. So force is Newton and distance is meter, and Newton itself, it is kilogram meter per second square multiplied by meter, so it will turn out as kilogram meter square second square. So C is the right answer for this. In question 6, the diagram below shows the velocity of an object before and after a force applied. The magnitude of velocity did not change. Which of the following arrow shows the change in velocity? So change in velocity, we draw the first vector. If we are using a triangle method, then we draw the second vector. So from tail of the first to the head of the last, that will be the resultant. So when we are finding the change in velocity, what is the formula to calculate change in velocity? It is final minus initial. So if this is u, this one is v, the change in velocity is equals to v minus u. So we need vector v and we need vector minus u, because v minus u in terms of vector, it means v plus and then minus u. So first we draw v. So first we do v and then we draw minus u. If u is upward, minus u will be downward. And what will be the resultant from tail of the first to the head of the last? That will be the resultant. So this will be our delta v, in which this one is v and this one is minus u. So B will be the right answer for this. Is it clear? Question 6, how we calculate the change in the velocity by vector addition. In question 7, trolley X and Y, masses m and 3m, are traveling at the same speed towards each other and they collide and move together. Which of the following statement is correct? So when we work out the statements, the first one, a force of X on Y during a collision is greater. That's wrong. They will apply the same amount of force. Force on X on Y during a collision is less than force on Y on X. That's also wrong. The speed of X after collision is greater than speed. The speed of X after collision is greater than V. So as you can see, the mass of X is m and the mass of Y is 3m. So when we work out their speeds after collision, because they mention the trolley collide and move off together, so final speed will be same. So it will be first mass into first speed. If this we consider positive, the other will be negative, plus the second mass, which is 3m, and the second speed is minus v, and they collide, they stick together, so it will be m x plus 3m x, where x is a final speed for 2. So when we solve this, it will be mv minus 3mv is equals to 4mx. If we further simplify, if we take like mv minus 3 mv, that is equals to minus 2 mv is equals to 4mx. M will cancel with m, then this will divide, so it will be minus 2v divided by 4 is equals to x. So what is x? It will be v divided by 2. So value of x, or the final speed of the system, will be half compared to the starting one. So which statement is correct? Statement D is the right answer. Is it clear? The combined speed of x and y will be less than the initial speeds at which they were moving. It will become half of their initial speed. In question 8, a popcorn kernel contained water. When heated, the water turned into steam and the kernel pops and move upward. So if kernel pops, kernel is moving upward, then the steam, the particle, water particle will move downward, because if initial momentum is 0, the final momentum is also 0. The photograph above shows the popcorn kernel just before popping at a maximum height after popping. The time between the two photographs is 83 milliseconds. Maximum height we need. So how we can work out the maximum height? The scale they give. So you will use this measurement, like if this is representing 1 centimeter, so the scale of 1 centimeter equal to figure size, you will use a ruler and measure this. So example, if this was 3 centimeter, so 1 centimeter is equal to 3, the figure size. So then you will do measurement, the position where this moves. So using this measurement, you will work out, using the scale factor, you will work out the height through which it will rise. So you have to use a ruler to work out this, or you can also use equation of the motion, in which s is equals to ut plus half at square, in which initial velocity is 0, so s is equals to 1 by 2 gt square. So we have the gravity, we have the time, so we can work out the distance which it moved. It will come out as 3.4 centimeter. The next part, calculate the initial speed of the popcorn kernel. So how we can work out the initial speed at which this kernel popped? So here potential energy, because kinetic energy changes to potential energy, so we can say half mv square, k is equals to p, and kinetic energy is half mv square and potential energy is mgh. So half mv square, half v square is equals to gh. So we have height, we have gravity, so we can work out speed at which it will move, because initial the kinetic energy changes to potential energy. The average water content in a popcorn kernel is 14% of its total mass. So 14% of the total mass, it contains water. The kernel is heated until it pops, steam is ejected downward and popcorn kernel move upward. Calculate calculate the speed at which the steam is ejected. So basically we will use the conservation of momentum, that if the kernel move upward, the steam will have the same momentum, but it will move downward. And the mass of unpopped kernel is 0.11 gram. So it is, and 14% of this mass is water, or we can say steam. So if initial momentum is 0, the final momentum should also be 0. So 14% of total mass, that is equals to mass of water. So when we take 14%, it will be 14 divided by 100 into the total mass, which is given 0.11 gram. So this will give us the mass of the water, come out to be 0.0154 gram. So the mass of the water is 0.0154, and when we 0.0154 minus 0.11, so it will come out as 0.0946 6 gram, and that is the mass of the popped kernel, and this is for water. Initial momentum is 0, so final momentum should also be 0. Conservation of the momentum. So momentum before is equals to momentum after. So momentum before is 0, so momentum after should also be 0. The mass of the kernel, that is 0.094, multiplied by speed. If it is moving up, they mention it is moving at a speed of 1.5 meter per second. So if this speed you consider positive, the other speed should be negative because it is in opposite direction. So 0.0154 multiplied by minus v, and when we solve this equation, so this will come out as 9.21 meter per second. So this is the speed at which the steam ejected from the kernel. Is it clear, this part? And question 9, an object of mass 50 kilogram accelerate from velocity of 2 meter per second to 10 meter per second. What is the impulse provided? Impulse is a change in momentum, which is mv minus mu. So mass is 50, initial velocity, final velocity is 10, minus mass is 50, and the initial velocity is 2. So this will be 500 and minus 100, so that is equals to 400. B will be the right answer for this. Then question 10. So a bullet of mass 0.1 kilogram, this is M1. It is moving, so this is the initial speed, U1 you can say. It strike a stationary wooden block, so that is M2. It is stationary, so speed is 0. And the bullets stick in the box, so there's a piece of wood, and the bullet, which was having a mass of 0.1 kilogram, moving with a speed of 600 meter per second, collide with a stationary wood of mass 1.9 kg. And then what happened after collision? They stick together, so move together, so their final speed will be same. So we'll use the conservation of momentum before collision is equals to after collision. So m1, the first mass, which is 0.1, the speed is 600, plus m2 is 1.9 and the speed is 0. After collision, the mass is 0.1 and the speed is x, and the mass is 1.9 and the speed is again x. So 600, it will be 60, and 0.1 x plus 1.9x, so that is equals to 2x. So 60 is equals to 2x. So x will be equal to 60 divided by 2. That's equal to 30 meter per second. So A should be the right answer for question 10. Is it clear? Discussion. So this was assignment related to topic momentum. In the next session, we'll discuss more questions from this topic. Any doubt related to the class today?